All right, here's the next video. What is SQL? And I guess I should have added a little bit to the last video. I do this sometimes. But aside from the microservices architecture versus monolithic, typically microservices is better, but it's also more complicated and harder to set up. And sometimes it's not always the best solution. Sometimes if you have like a smaller app, it's better just to like code everything in one place and avoid the complexity of the microservices. So you can take it on a case by case basis. Aside from that, part of the microservices architecture is the it's like one of the benefits of that, although it's not necessarily exclusive to it, but part of that, I guess, I don't know, that the concept of that is being able to make like API calls and get services from other places and use them. Which again, I'll have to think about that. That's not necessarily specific to microservices, but that's the general idea. And so like a practical example being something like Google Maps. So Google is a huge company. They spent a lot of time trying to map out all the roads of the world, right? And how do I get from point A to point B? And because they did that, it's like, we have very nice. That's a very nice feature and functionality you can use to. Now we don't have to carry physical maps around. It makes life easier, and it has a lot of applications as well. I mean, as an example, let's say like DoorDash wanted to use Google's map data, to help their drivers get around, right? To do that, they could either go and reinvent the wheel and try to like create a map of the world's roads just like Google did and spend all that time and energy trying to do it. Or they could just talk to Google and say, hey Google, we know you have this cool map service. Could you let us use it? If you do, maybe we'll give you some money or something like that. We'll trade you. And so like the having that service, Google created it, and because they can offer that service through something called like an API, which is like an application programming interface. And I talked about the internet a little bit. The internet connects the internet devices talk to each other across the internet through a protocol called HTTP. And so that's basically just like a set of rules to say, hey, I want to communicate with you, and here's how we're going to do it. I'll send this kind of message or this kind of thing, and then when you see it, you can interpret it and understand it, and then you can send some kind of data back to me. And there's other rules like, hey, how many if I don't hear from you right away, how many times should I retry before I just say, okay, the request failed. So things like that, or how do I make sure that the data I sent, that all of the data gets there? So at least I believe that's technically the proper technical terms and description for it. But whenever you visit like a website, some URL links are also just like API interfaces, so application programming interfaces, which is basically, if you go to that special website, it'll send you JSON data back. And that's how you load up, like the different picture, video data, or how you use someone else's data, like the Google Maps data. It can be provided through that kind of means, an API like that. And again, that makes it very useful because now smaller companies like DoorDash or maybe like maybe a mom and pop tourist company creates like an app or a website, and they're like, hey Google, we want you to put us on your map, like put a pin where we are, or help you direct users to our website or whatever, and so they can come to some agreement with Google or Google can. I think Google might offer some of that for free or all of it for free, because a lot of these a lot of these kind of free services, like in exchange for when you use them, they're also tracking everything that you do, so that, hey, when you use their map data, okay, yeah, they're provided to you for free, but in exchange they have a record of, oh, hey, Delta Peng, he likes to visit these Mexican restaurants on Tuesday, or oh, he goes to groceries, he goes for groceries every once a month or something, and he goes to Fry's to get ice cream when it's 100 degrees out, or but when it's 90 degrees out, then he won't, or there's like a when it's 100 degrees, there's like a 20% higher chance that he'll go and do that. Basically they just have a bunch of data and they try to figure out patterns from it, because if they can figure out like a patterns, like, oh, Delta Peng likes to eat ice cream at this time, at this store, in this temperature, and then they can tell Fry's and be like, hey, we have this customer that really likes your ice cream. And, if you, I don't know, if you pay us some money, we'll put up a Fry's ad when those conditions occur, and that'll get them thinking about it. And then maybe that'll increase the chances that it'll come in. Or it could be or maybe if they get enough data, like Amazon, if they get, they record your buyer history or something like that. If they get enough data, they might see, oh, this person likes this kind of book. Let me see all the other users that like this book. What did they buy? Okay, they bought this book next. And so I'll recommend that to you also, because, since you bought this book, there's a better chance you'll buy this other book that similar people are interested in. And so they harvest and use that data to try to create more sales and generate interest, or sell that data to companies, things like that. So that's kind of where they get their money from, or maybe ad revenue or other stuff like that. All right, so that's a lot, but that's again, that's some of the architecture stuff and how some of the things are happening in the background. So like one company can, but the benefit of that is like one company can create like a really cool interface or thing, like ChatGPT or something, and then offer it, because it's not tied to just one program per se. They have a means of creating an API and offering it to the world, or for others to use. Okay, that might be more just API stuff. They can structure it in a way that other people can access it, and that's not necessarily tied to monolithic or not. But the idea of microservice architecture is to keep things separated. So instead of like one program, gets the data and processes the data and saves the data out, maybe it'll be like, we'll split it into like, okay, the program gets the data and then it sends the data to like a different server, and this server processes it, and then it sends it to this server, and then this third server is the one that saves it. So by splitting it, chunking it out like that into like microservices, then, if some other company's like, hey, I need to save out similar data, can you save that out for me? Then they can just talk to the third server and be like, okay, yeah, we'll just adjust this code and save this data out for you, rather than having to be like, okay, yeah, but it's all tangled up in one program and we have to figure out, and it's not designed to take care of your data. So we have to figure out how to extract it and do what we want, what you want it to do. So the microservices architecture is definitely more leaning towards that kind of shareable API type, I guess, setup. All right. So anyway, what is SQL? SQL is structured query language, and so it's not exactly like programming. It's like a programming light in a sense, but it's a way to structure the data that you store, and then you write certain commands. The query language, you write certain commands to be able to get that data back. in a convenient fashion. You store it efficiently, and then you have a way of efficiently searching through that data for what you need, and then returning potentially limited data of hopefully just what you need back. And it also helps reduce duplicate data. All right, so let me see if I can go and explain that for you. Give me a sec. Okay, I think we're back on. All right, back on. Record. Yep. All right, let's see if we can do this. Okay. So structured query language. So going back to, okay, let's use an example of, let's say we're Amazon. Okay. Let's say we're Amazon, and it starts with just, I'll start with a little bit of data. So now we want to create a site like Amazon, which is, like a digital storefront, right? And so how would we structure the data if we were going to be something like Amazon? All right. Well, Amazon's online store, so you could do something like, oops. Give me a second. It's an online store. So one aspect of the data that you would be interested in, right, is like orders, right? Because they have probably millions of people visiting their site on the regular and buying things. And so you want some way to keep track of that, because, order history is important. You could use that to sort of determine users' buying habits and then try to recommend more things to them. Legally, there's also an obligation legally to be able to track that. Because if at the end of the year, Amazon's like, hey, we owe 100,000 in taxes, or 0 in taxes, then the government's going to be like, I don't think so, man. I think you owe more than that. And, I can prove it to us. Then they could be like, okay, this year we made $1 million, or we had 10,000 orders, or 10 million orders, or whatever number you want to put to it. And here's how much we made. We made $1 million, but we paid $1 million out to our employees. So our net profit is 0. We didn't make any profit, because we paid it all out. Or it's like, okay, we paid the employees, and then also we had, one of our companies, our machinery broke down, and so we had to spend an extra $200,000 to repair the robots or something. And so that counts as a business expense that isn't taxable or something like that. And, because the robot company that supplied it would pay the taxes instead, something of that effect. And so they would have to have records to prove and show that. But then, as mentioned, it's useful to have that either way, because you can use that to say, hey, this user buys a bunch of arts and crafts materials, so let's advertise that to them. Or this user, only buys, movies when they're on sale, so let me just put the movie deals in front of them. Stuff like that. Whatever they can do to try to generate more business, more profit, is what they want to aim for. So how would the data look for something like that? Well, you would have something probably like an order number, the name of the person who bought it, right? The name of the seller, what the item name was, what the price was, at least when they bought it, where to ship it to. Oh, here we go. Yeah, that was an adjustment for later. So like where to ship it to. So okay, here's this address here, and then stuff like that, right? And when it happened. So the issue, that's fine. Like, okay, so Delta Penguin, he just joined Amazon and he bought an item. Cool, we want your business. Thank you for your business, Delta Peng. But then let's say Delta Peng has a spending problem. So like, okay, not just one item, but Delta Peng bought, and this is kind of where I went down here. Delta Peng bought, let's say, 5 items, and they bought 5 items, and they got in the habit of buying 5 items every day. So I'm sure the first few days they're like, okay, cool, he's buying more items, cool, keep on coming back. But then after like day 30, you might be like, I think this guy has a problem. He just keeps on, like, okay, now he has, he just keeps on buying and doesn't stop. In some ways, it's good for them because it's like, okay, we have the more business, the merrier. Assuming we're making a profit, that's a good thing. But one problem that comes with that is like, well, as much as we like the money, we also we want to create an efficient business to try to maximize our profit. And to do that, we need to, not repeat data if we can help it. So, one example, the first time it's like, okay, cool, here's the address, send it to this address, you bought an item. But, like 30 days later, you bought like 150 items, and I kind of use this as an example. I did a bunch of copy pasting. Then it's just like, so what's the problem with all this data here, you see? So one of the big problems is that you see duplicate data. And again, pretend like the seller name is different and the item is different and the price and stuff. But the one thing that would be consistent is like, hey, Delta Peng's the one who bought it and he's shipping it to the same address, And so it's fine if you just do it a few times, but if you do it like 100 times or 1,000 times over a year or multiple years, then over time you like this data file is going to get huge, and a lot of it's just redundant, unnecessary data. You just we don't need Delta Peng's address 1,000 times. We just need it once or maybe a couple times. So how do you avoid that data duplication and unnecessary redundancy? And SQL is like SQL is part of the answer to that question and that problem. Let's see. And the way that it resolves, we'll stick to one thing at a time. And the way that it could resolve that is instead of having like, again, that address repeated everywhere on this table of instead of having the address repeated everywhere, we could separate the data out into a separate table. Okay, so I haven't explained tables yet, but the way SQL arranges data is that it will use, you create a table, something like this. So based on the orders, it would be like, okay, using the SQL language, you'd say create table. So that's a special command. And then you name it something. So create table orders, and then you give it what the properties are of it. And, you could say that this looks kind of similar, right? This looks just like, it's pretty much very similar to JSON. It's like the order itself looks like this. So it's an array. In this case, there's 3. I think I put 3 orders here. But they're all, same properties. You need order number, name of seller, name of buyer, item name. So SQL table is that you would define it as like, hey, here's the object that I'm looking to store into this table. It would be some object with the order name, name of buyer, name of seller, etc., etc. And so it's kind of like you're sculpting the custom made container that you want to store your data into. Yeah, that's a good way to look at it. So you're custom sculpting it so that you don't waste data, waste space. Like it's kind of like, when you ship a package, if you're shipping a box of a box of playing cards, you can use a small box, right? But if you're shipping a piano, you need a much larger box. So similarly, in terms of like digital space on your server or on your computer, you don't need to use like piano-sized boxes to ship playing cards to sellers or to whoever bought it. So creating the table is a way to custom create the container so that you're not wasting a lot of space in essence. And then you're also telling it the data type of, hey, I want it to be a date, a timestamp, or varchar means like a variable character. So the name of the buyer could be up to 200 characters, which means like up to 200 letters or numbers or stuff like that. It could be less, but up to that amount. Order number is an integer. And then this is a special command to say something kind of like, hey, create this for me and just use the next number in the list. So like when we have a list of orders, it's like, okay, 9, okay. So when you create it, it's like, okay, the first one's, or this one's, X million and 900, X million 901, X million 902. So the order number is kind of being auto-generated whenever a new object is created. Oops. Okay. Yeah, sorry, it's a little bit. Yeah, so it's being auto-created whenever these guys are added to the table, or in SQL language, whenever you want to insert a record or insert an object. This is the special command you'd use. You'd say something like insert into the table of orders, which is the one I created up here. And what values do you want to put into it? Okay, let's see. I want to name buyer. So I'm skipping order number because if I skip it, it will automatically create it if it can. I want to put the name seller in. So that would be like, okay, Delta Pen, Connor Peng, and then et cetera, et cetera. And then if it has a default value, again, it's like if I skip date created, it'll put in the default, which is just whatever the current time is. This is a special variable here, or command. Okay, so creating the table is how you insert or put the data in, and then the way that you load the data is running SQL kind of like this. So what is this saying to us? This is saying, hey, select or get everything from the orders table, but only where the name seller is, and then you can filter it by having different parameters here. And then here's the kind of data that you want to come back from it. Okay, so the example I use here is, okay, so that's one table, and then instead of having okay, the address everywhere, and Delta Peng's buying too much and he's clogging our servers, and we have his address 1,000 times for some reason. So instead of doing that, what you can do is create a separate table just for that information. So instead of the orders table, I'm also creating an address table. And how would I connect all these orders together? It would be like, well, the only thing I need to know is who is the user, who's the buyer, basically, right? Who's the buyer, and what's the address, and maybe like what's the type? Is it a shipping address? Is it a billing address, etc.? So I can So I create that table, and add like a record like this. So from now on, if I do that, then from now on all these order tables, I can. Okay, yeah. I jumped ahead in my examples. So in all these order tables, it's here somewhere. Yeah, all these order tables, so instead of having this address clogging everything every time, I can just replace this with something to connect it to something like this. Something to connect it to Delta Peng's shipping address. So all I need is the username and say like the type. And if I have that, then I can get the data from the address table, right? So instead of clogging it again of like this everywhere, this load of data, I can just say, okay, address to ship to, and use the shipping address. And then this data already existed, so I just use these two to get the data from the address. So now all the other 1,000 order entries or whatever, you can replace that data with this data in essence. And so it helps shrink it down. It keeps it, it's like good code. It keeps the information in one spot rather than having it in 1,000 different places. And yeah, and then if you need to change it into one spot, changes it everywhere. But because this is like, what is the purpose of this table? It's to like record, the orders that you made. Because of that, it might not be, you might even want, okay, it's duplicate information, but maybe it's useful in case like, you need that order history or something. Maybe you need to know exactly where you sent it, that specific order. And so in that case, maybe you don't want to separate it out, but you have to decide that for your app. But some of the power of SQL is that, okay, let's say, let me put some of these guys back, this data. So one example is, okay, Delta Peng ordered 1,000 things, but unfortunately, one of the things Delta ordered says, okay, hey, I ordered this rare amiibo, and it wasn't the one that they said, they didn't send me the right one. And I was supposed to get, I don't know, I was supposed to get Palutena, and they gave me the squid, the squid, not the squid kid, just the plain squid amiibo, which, is not the one I wanted or something like that. So if that's the case, then like, you file a request to Amazon, right? It's like, hey, this is not what I ordered. And then Amazon could go back and be like, okay, let me see. Oh, it looks like, here's the order number. It looks like you ordered from this guy here. Oh, and his name is Sql Pt1. And okay, you're right. It looks like you ordered the rare amiibo, and the picture you sent us isn't the same thing. So it looks like you got it wrong. So we either need to talk to this guy, or like, let's say maybe something fishy is going on with his account. It's like, okay, this is like the third time it happened this month. We think, maybe this guy is a scammer. Maybe he's not legit. So how would you find that out if that was the case? Well, I mean, if you had all the data in like a text file like this, you could sort of look through it and be like, okay, well, I need to find out everything where Sql Peng tried to sell something, right? So I could try, if I have a text file, I could try doing like a text search. A text search, which kind of works, but then if he was a buyer, in some cases, that probably doesn't matter. I think it's mainly the seller. Is when he's a seller, that's the problem. What if he sold to poor old Grandpa Peng, and he sold him like a reliable walking cane for almost $1,000. But then we could be like, okay, well, if we already got 3 complaints about him, maybe this isn't actually as advertised, and maybe he's scamming him because that price is also ludicrous. But how would you, how would you find that? It's really hard to look at it in this file, right? It's like, okay, well, maybe, well, there's, let's say 100 entries. Am I going to just manually look at every single one? Even, I narrowed it down a little bit, but that's only does so good. What if my boss comes and says like, okay, well, we gotta stop this guy, but how do we know if he's like a petty time thief and it's just selling like toys that are like bootlegs, or whether he's legit, like, okay, now he's selling like that walking cane for like, again, $999. Oh, here we go. I have two of them. $999, and like, okay, scamming people for larger amounts. It's like the police have come to us and they want to know, is this guy a petty time thief, or if he's conned anyone for more than $1,500 or something, then that would be a federal offense or something like that, or more than a misdemeanor. Then like, how would I, I wouldn't be able to easily find that out. I couldn't just do like, oh, 1,000 to try to get like over $1,000 because maybe he sold something for $1,100. That's not going to match, right? When I look at the data, if I'm just doing a text search. So this is where SQL comes in, because when you're doing SQL, you can select get certain values back, and you can put specifics like, hey, give me everything where the name seller specifically is Connor Ping, and the item price, because it's a number, I can do a conditional, kind of like, greater than or equal to, as I say, 1,500. If it's greater than or equal to 1,500, then it becomes a larger offense. So if I did this, then SQL will look through the data for me, and it'll give me back just the items that meet these conditions. And note, this is kind of like the code, right? Instead of like the and, it's a bit different. So SQL uses a bit different language, or SQL uses like and or, just the word, where in the programming language it would use, okay, this for or. Okay. So that's the power of SQL, to be able to prevent duplicate data, and it'll give you power to really filter things out. And in the next video, I'll show you through the W3 Schools website I'll show you it running in action, an example.